So in chapter 5, we've been working in previous sections with polynomial functions and rational functions. A lot of our polynomial functions you really can't find the inverse for. But the ones that you can, they're called invertible functions. So if you can find the inverse of the function, then it's said to be invertible. A lot of our simpler functions from our toolkit, like an x squared, a quadratic, or a cubic function, we can often find, if they're not too tricky, if they're fairly simple, we can find an inverse for them. Higher exponents, probably we're not going to see a lot of that. Let's see. So, invertible functions. Also, I just wanted to mention that if it has a radical in it, like our last one, we had the square root of 2y. We had x equals that. This is called a radical function because it has a radical in it. And we'll see some more of that in this section as well. Okay, and how do we verify that two functions are inverses? Well, if you compose them, if f compose f inverse of x, and remember that can be written f of f inverse of x like this, that has to equal x, and then it also has to work the other way. So remember, composition is not commutative. So in this case, though, it has to work both ways. So f inverse of f of x also has to equal x. And that's how you verify if two functions are inverses.